All right, so we're going to look at some application problems for scatter plots. And in this situation, we're told that with the help of scientists, farmers in China have been able to produce more and more grain per hectare each year. Here are the crop yields for several years, okay? So they give us this table here in which we can label this our X values and our Y values. And for our X values for the years, we have 1962 through 2006, and they label the yield of kilograms per hectare from 1,360 to 5,050. Okay, so that's the crop yield in kilograms per hectare. Okay, now they also give us this information here, which says the crop yield can be described in this equation: y equals 92.5x minus 180,000, where x is the year and y is the grain yield in kilograms per hectare. Okay, now all of this is plotted here, our x and y values, okay, where we have our x-axis and our y-axis. Okay, these are our points that are plotted in our scatter plot, where x represents the years and y represents the yield. Okay, now notice they created this guy here, this line that seems to run through it, the general trend that seems to be as we plot the points. This guy right here is the trend line, or sometimes you might hear it as the line. Whoops. The line of best fit. Okay, because it's the line that best matches the data. It shows the general trend of the points as we plot them. Okay, so this guy right there, that's our trend line or line of best fit that best matches the data. Okay, so we have our years, we have the yield, we have our scatter plot. What we want to be able to do is understand what the information is saying and then apply it so that we can find a given information or find a certain information. So it says on A, what does the slope of the line represent? Okay, well, when we're talking about slope, remember we're talking about the rise over run. And in this case, our rise of a run, we can think about, remember when we had a table, it was our change in y's over change of x. But even though before, when we looked at change of y versus change of x, it's not so simple now, okay? When we're talking about a scatter plot, things aren't necessarily consistent with our slopes, okay? Instead, what we're really trying to determine here is, in general, what does the change in the y over the change of x represent? Okay, well, our y values represent the yield, and our x values represent the years, okay? So as we increase, think about the general trend here, okay? Look at our scatter plot here. What kind of correlation do we have? It's a positive correlation. The trend line shows that we're going up. So as x increases, doesn't y also increase? Yeah, so the general idea here in terms of y over x is that the increase in the crop yield, or the increase in the crop yield, is every year, okay? Okay, so in terms of y's over x, this goes up as this goes up, okay? Now, in the table format, it's actually going this way, but as the numbers go up for the yield, the numbers go up in terms of the years, okay? So as the years increase, the yield increases as well. So we could say that the increase and our yield here in crop yield every year. Okay, the increase in crop yield every year, that's what the slope represents. It's the increase in that crop yield every single year. Okay. Now, in terms of the next question, it says, according to the model, what was the crop yield in 1987? Now, we could get an estimated guess by looking at our actual scatter plot here and kind of making a trace line from our x values. Now, this is 1980, so this would have to be 1990 and then 2000, right? Well, 1987 would be somewhere in here. So if we're going up to our y values to try and determine what the yield would be, we can kind of get an estimate here. It looks like maybe if this is 3,000, this would be 3,000, 3,500, on the Y values, right? 3,000, 3,500, 4,000. It looks like it's maybe 3,700, maybe 3,800. That's what this guy looks like it is right there, okay? Now, that's just a guess, though. If we want to find it mathematically, remember the years, the dates here, they represent the X values. And we're actually given an equation that we can use here. So I can take the year, plug it in for X, and see what I get for my crop yield, Y. Okay, so we're going to take that value, or we're going to take our equation. We should write that first. Y equals 92.5X minus our 180,000. And we're going to take our X value here and plug it in for X. So Y is equal to 92.5 times 1987, that's the year, minus 180,000. Okay, now this is something that we can do in our calculator. So if we take our calculator, take 92.5 times 1987, and then subtract our 180,000, we're going to get approximately, if we're rounding to the nearest whole number, 3,798 kilograms. Okay, make sure we're using the right units here. Kilograms per hectare. Kilograms per hectare. And HA is what we want. Okay, so this would be my answer. Okay, so it says, according to the model, what would the crop yield be in 1987? Well, approximately 3,798 kilograms per hectare. Okay, and that's kind of what we guessed earlier. We said it was like somewhere between 3,700, maybe 3,800. So we're pretty close there. Okay, now if we're working backwards, instead of being given an X and finding a Y, maybe we're given a Y and we want to find an X. It's the same idea. Okay, so it says the model indicates that a crop yield of 3,200 kilograms per hectare was achieved in what year? So now we're given the Y values. We're given a yield and we want to find a date, a year. So again, we can kind of use the idea of kind of tracing. I'm going to kind of get rid of the tracing we looked at earlier. And we can kind of find where we think 3,200 would be, and just kind of go across and then go down. Okay, so this is the Y values. We're looking for the X values. So it looks like if we're at 3,200 over here, we might be about 1981, 1982. So maybe the year's 1981. Okay, so that's my guess there looking at the chart. Then if we actually want to find it, again, we can use our equation, Y equals 92.5X minus 180,000. But this is now a Y value, so we're going to plug that in for Y. Okay, and then solving for X here, two-step equation. The opposite of subtracting 180,000 is adding it to both sides. Okay, whoops, adding it to both sides. Oops, go back. So we have 3,200 plus our 180,000, and we get 183,200 is equal to 92.5x. And then we have 92.5x times x, so the opposite of that would be to divide that to both sides. Divide that to both sides, and dividing that out in our calculator, we get approximately pretty close. If we're rounding to the nearest year, looks like 1981. Okay, well, that kind of matches our guess that we talked about earlier. We said maybe it was 1981, maybe it was 1982. So the year is going to be 1981. Okay, so that would be our answer there. So when we have a crop yield of 3,200, this was achieved about 1981.